All right, here we go. Unit 2, Lesson 2, Practice Problems. As an FYI, I'm just winging these, hoping that my knowledge is enough to figure them out. I don't have the answers. I don't want the answers. It's more fun if you don't have them. But I realize sometimes we need a little help, so that's why I film these. Who is your athlete today? It is Marshawn Lynch. So I'm a Niners fan. But I'm not like crazy. Like I can appreciate other teams and other players. One of those people was Marshawn Lynch. A little about Marshawn. He was the running back for the Seattle Seahawks. And they had a chance to win a Super Bowl if they would have just handed him the ball on the 1 yard line. But they called play action, and Russell Wilson threw an incompletion, and the Seahawks lost their chance to win their second Super Bowl. But Marshawn Lynch was an entertaining player. Look up the run he had against the Saints. I want to say it was Darren Sharper. I can't quite remember. Anyway, I did this cool thing in the end zone. And also, Marshawn was hilarious. He's from Oakland. He ended up playing for the Raiders. He went to Cal Berkeley. You can go to Cal Berkeley too. Like Cal Berkeley is a great school, and it's like right in our neck of the woods. So they prioritize a little bit, like locals from Richmond. So shoot for the stars, you know. Even if you miss, you'll or shoot for the moon. Even if you miss, you'll end up among the stars. But anyway, Marshawn Lynch, cool, funny interview. All his interviews were pretty hilarious, but one of the ones I remember is he kept saying, "I'm just here so I don't get fined." So everyone was asking him questions in a post-game interview, and he had gotten fined like a couple weeks prior because he didn't want to do interviews. But anyway, he kept saying, "I'm just here so I don't get fined." That was his answer for every single question. It's pretty funny. But Marshawn Lynch, he was a beast. He was a crazy good running back, and he's my featured athlete. This was also a gift from one of my first year students. He had given me a bunch of his old cards. Some of them are worth a lot. I wonder how much this one's worth, but looks like his rookie card because he's in the Cal uniform. All right, here we go. Lesson 2, practice problems. Yes, I like geometry, but also I like other stuff. Okay, lesson 2, practice problems. Line SD. Let's look at line SD. So they're talking about line SD, not line segment. So let's extend that puppy. Okay, so there's line SD. Is a line of symmetry for figure AXPD ZHMS. Noah says that AXPDS is congruent to HMZDS because sides AX and HM are corresponding. So AXPDS congruent to HMZDS. I already see a fault problem here. He didn't go in the right order. AXPDS should be MHZDS. It shouldn't be HMZDS. These are switched. Okay. Why is Noah's congruent statement incorrect? Oh, answered my own question. Or my own observation. Wrong order. Wrong order. AXPDS is actually congruent to MHZDS. So he missed. Maybe he's dyslexic, but M and H were switched around. Write a correct congruent statement for the pentagons. There you go. Cool. One down. All right, figure 2. Figure MBJKD G, H. So this one right here is the image of A, F, E, K, J, B after being rotated 90 degrees counterclockwise about point K. Okay, so what they did is they went like this. A, F, E, K, J, B. Let's just write it down. A, F, E, K, J, B. So if you rotated 90 degrees around K, after being rotated 90 degrees counterclockwise about point K. Okay, so that's what they're saying. So A, M, C, A and M line up. F and B are in order. E and J, yep, E and J. K and K, yep. Okay, so that's what they're saying. Draw a segment in figure AF, E, K, J, B to create a quadrilateral. Okay. Draw a segment in this one to create a quadrilateral. Okay. I think I can do that. Let's do that. Here you go. Draw a segment to create a quadrilateral. Let's just go like this. E to B. Already got points made. I was going to just extend this down, make two rectangles, or maybe a rectangle and a square. But it's even easier if you use points already. So EBK or EKBJ or gosh, EKJB or BEKJ. Here we go. It's right here. Okay, so we made a quadrilateral. All right. Draw the image of the segment when rotated 90 degrees about point K. Okay, so if we rotate this thing 90 degrees counterclockwise about point K, then I have to draw the image of that segment. This was the segment I drew. Okay, you can pick any that makes a quadrilateral, but all right, no problem. That's pretty easy. Use your tracing paper. E, K, J, B, B, and E. That's the segment that I drew right here. Use dash lines to get around the imperfection of drawing a long straight line, but 90 degrees, center K, counterclockwise. Okay. So I know that EB is going to have to end up forming a 90-degree angle. So it's going to end up right there. Okay, got it. So because EB is going to go 90 degrees counterclockwise, you got to get a 90-degree angle on the angle of rotation. Watch what it does. Center K. There you go. Okay. It's going to be, EB is going to be JH. Write a congruence statement for the quadrilateral you created. This one. That's the quadrilateral I created. And the image of the quadrilateral in this one. Okay, so my quadrilateral is named E, K, J, B, congruent to, and let's just run it one more time. So if I start with E, you gotta figure out what the new one is. It is J. So, sorry, I lost my train of thought. So it's gonna be J. The K is gonna be K again. J, K. this J will be G, and that B goes to H. Whew, there you go. All right, tough problem. It's okay. Tough problems are fun. So what does that mean? It means the orange one is congruent to the red one. And I got the order correctly. Order matters. Order matters. Remember that, please. Order matters. Okay, number 2. All right, number 3, here we go. I'm gonna zoom out just in case. All right, triangle, HEF. So you gotta identify it, that's right there. So triangle HEF is the image of triangle FGH. So H and F line up. E and G will line up, will correspond, and F and H will correspond. Okay. So HEF is the image of FGH after a 100-degree rotation about point K. You may be like, huh? Well, let's show you what that means. So I'm just going to trace it for you. H. Give up on that one. H, G, F, and K. H, G, F, K. All right. Let's just connect these real quick. This is why you gotta put your phone away when you're doing this homework. Stuff is tricky. Okay, so what they're saying is a 180-degree rotation about point K will result in this one, which I shaded. All right, select all statements that must be true. Well, before I even do that, I want to start doing my corresponding parts. So boom, 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 boom. This one's shared. You might want to rewrite these things. H, E, F, F, G, H, meaning that up here is going to be congruent to here. E and G. Last but not least, that one and that one. All right. So you've labeled your figure. You gotta be really careful on the order. Really careful on the order. Be really careful on the order. So triangle FGH is congruent to FEH. You might initially think yes, but look at this. FGH. If you're going FGH, it has to be congruent to HEF. They wrote FEH. That's not the same as HEF because order matters. This cannot be true. Triangle EFH. Okay, so 2, the second, the third, and the first. It's going to be congruent to GHF. They said GFH. Not good enough. See how rewriting these over here can help you? All right, angle KHE. Well, you already know that's going to be congruent to, K is going to stay put, KFG. This and this. KHE is this angle right here. You know it's going to be congruent to KFG. Yep. Boom. All right, so I got you one of them. There's probably a couple more, but you need to know this. Order matters. If you select one that's out of order, you're going to get it wrong. Okay, number 4. When triangle ABC, this one right here, so when triangle ABC, I could have just done a quick shading. Oh well, I like to take my time. When triangle ABC is reflected across line AB, just quick reminder, a line goes forever in both directions. So when we reflect this purple triangle over this line, the image is triangle ABD. Okay, so ABC, ABD. That's our order. ABC, ABD. ABC, ABD. Okay. Why are segment AD first and third and segment AC congruent? Okay, so why is AD congruent to AC? This is going to be this concept. I'm almost sure of it. Corresponding parts of congruent figures are congruent. That should be the answer on one of these. But let's see. Congruent parts of congruent figures are corresponding. Not necessarily. Corresponding parts of congruent figures are congruent. That's for sure. True. An isosceles triangle has a pair of congruent sides. It does, for sure. This whole triangle, ADC, the bigger one, the white plus the purple, it does have a pair of congruent sides. However, that doesn't explain why AD and AC are congruent. Segment AB is a perpendicular bisector of segment DC. It might be. Yeah, it is. It's perpendicular. And it bisects DC. However, that doesn't prove that this and this are congruent. The one that does is right here. Corresponding parts of congruent figures are congruent. Tough question, but you needed to know that. All right, cool. There's 4. 5, Elena needs to prove that angles BED, this one, E's in the middle, so angle BED and BCA are congruent. Needs to prove this. We have to prove this. Okay. Provide reasons to support each of her statements. Line M is parallel to line L. It sure is. So we got to add some flavor to this. So yeah, line M is parallel to line L. The next thing is angles BED and BCA are congruent. Whoa. Add reasons to support her statements. So why is M parallel to L? I'll write that right here. Why? Why do you know that M and L are parallel? And I'll show you. See this one and this one? Line M is parallel to line L because AB is a transversal and we were given that angle BDE, this one, is congruent to angle DAC. Thus, because there are corresponding angles congruent, the lines must be parallel. All right, tough problem, it's okay. Angles BED and BCA are congruent. Why? Why are those congruent? Because these are congruent because BC is a transversal across parallel lines M and L. That's the symbol for parallel. Parallel lines M and L. These are congruent because BC is a transversal across parallel lines M and L. And BED and BCA are corresponding angles. Whew, tough one. All right. 6, triangle FGH. This one. So triangle FGH is the image of isosceles triangle FEH. So you automatically know that and that because this triangle is congruent to this. After a reflection across line HF, there's line HF. So we're reflecting over this line of a reflection. Got it. Okay. Cool. Select all the statements that are a result of corresponding parts of congruent triangles being congruent. Well, before we answer these, let's start marking off our figure. So I'm going to do an arc with a 1. And then I'm going to do an arc with a 1. Then I'm going to do an arc with 2. An arc with 2. And then over here, I'm just going to do 3. Okay. And then you also know that this one is shared. So here we go. Now, don't forget the order matters. So what do you need to rewrite here to help you? Right? FGH big is the image of FEH. So the F's line up. The G and E line up, and the 2 H's. All right, cool. EFGH is a rectangle. You see 4 right angles? I don't. EFGH is a rhombus. Yes. Rhombus. Let's talk about rhombus. All sides same length. Opposite angles congruent. opposite sides parallel. You have to decide if the big one, E, F, G, H, has all sides the same length. Yes. That, and that. So that checks out. Are opposite angles congruent? Yep, 2 and 2. And then this one is 1 and 1. This one is, wait a second. Oh yeah, it is, because it's isosceles, silly me. Yes, opposite angles are congruent. Are opposite sides parallel? Yeah. Yep. They are. HE is translated by directed line segment HG to get GF. EF could be translated by directed line segment EH to get HG. Or GH, I should say. All right, diagonal FH bisects angles EFG and EHG. You needed to know that this is an isosceles triangle, so that and that are the same. And if we reflect over FH, then also that and that are the same. Meaning that yes, it does bisect the larger angles because each of these individual angles has the same measure. Whew, tough question. Diagonal FH perpendicular to side FE. FE? FH? Are those perpendicular? Nah. Perpendicular. I can almost always find an example. There's one. Perpendicular means 90 degrees. Is FE perpendicular to FH? Nah. Angle EHF. Is it congruent? So this one right here. Is it congruent to FGH? This little guy right here? Congruent to this one? Nah. No chance. One's obtuse and one's acute. Can't be. Angle FEH. This guy right here. Is it congruent to FGH? Oh. Go back to the order. Just triple check. F's, GE, H's. Yeah, we're good. Whew. 6 is tough. 6 is tough. Oh well, who cares? Tough problems are fun. Last one. This, oh, it's from a lesson we didn't cover. Oh man. I'm gonna try it. Let's try it. I've never seen this problem in my life. Okay. This design began from the construction of a regular hexagon. Okay. They were doing that circle compass moves to get the regular hexagon. Okay, cool. Pretty cool design. And there's another one out here. All right, draw one segment so the diagram has another hexagon that is congruent to A, B, C, I, H, G. Oh, okay. I think I see it already. There we go. That'll be congruent, I think. So yeah. So this red one right here will end up being congruent to this gray one. Okay. Explain why the hexagons are congruent. Of course. Well, that looks like a line of symmetry. I'm just going to triple check. Why is the gray and the red, why are they both congruent? I'm just getting all scribbly. Who cares? Scribble. Doesn't have to be perfect. All right. Why is the gray and red congruent? Everybody see this line of symmetry right here? That's what I'm looking for. And I'm going to prove it with a reflection. Okay, so if we reflect over line AD, line of reflection AD, that means A is going to stay put. Yep. Okay, so check it out. This is how you want to do it. A, B, C, I, H, G will end up being congruent to so A, B, C, I, H, G is congruent to A, B. So A, F, E, K, L, G, because we reflect the pre-image, this gray one, or we reflected the pre-image over line AD. And reflections are rigid transformations. And in a rigid transformation, the pre-image is congruent to its image. Woo! Party on, geometry. Okay, lesson 2, congruent parts, part 2. All right, write a congruent statement for each pair of congruent figures. All right. Order matters. Order matters. That's the big challenge on this one. Okay. O, P, L, M, N. O, P, L, M, N. I'm gonna go O to Y. Think we rotate counterclockwise till N lines up. Yep. So OPLMN congruent to YAHFS. Okay. DCEF. F. E. DCFE. Okay. Translate D to X. Rotate counterclockwise until C aligns with W. DCFE congruent to XWVU. I think I covered up the answer. Boom. Rotate. Just line them up. D with X, C with W, F with V, E with U. So you're going to say DCFE congruent to XWVU. It's a ton of right answers on this one. ONM. I'm going a little sloppy, which is going to mess me up a little bit. You got to be careful. Okay. I'm going to go M to T. So translate M to T. Rotate clockwise till N aligns with E and O with U. Now you could say MON congruent to TUE. I'll do the last one. Monday congruent to Tuesday. No, it's not. Just kidding. They're trying to be clever there. Illustrative math. You're funny. All right. Monday congruent to Tuesday. Not in our bell schedule. All right. Adios. That's a quiz question. Darren Sharper. Just kidding. See ya.